Hello students, welcome back to today's class on probability, and we are in lecture number 2. In the last class we discussed what is probability, and also we discussed a couple of applications based on that, and let's try to discuss more applications on what all we have learned in the last class. My name is Avinash and I'm a graduate from IIT Kharagpur. Let's start today's session. So what is probability? What we have discussed in the last class, right? So we have discussed probability is the occurrence, right? Is the percentage of the chances to win. Right, we have discussed probability in the normal terms, and we discussed a couple of examples too. Right, I'll give you one more question so that you can understand more better about this. With this, we have stopped the last class. Once again, let's try to continue with that step. Right, what is the probability that a number selected from the numbers 1, 2, 3, and so on 15 is a multiple of 4? Number which is selected is a multiple of 4. So what is that meaning? Okay, so 1, 2, 3, and so on 15. Here we have 15 numbers. Let me write all those. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 is a multiple of 4. It's a multiple of 4. So what is that multiple of 4? So 4 into 1, 4 into 2, 4 into 3. Do we have any other number? Do we have 4 into 4? No. Right? So what is the probability that number selected from the numbers 1, 2, 3 and so on 15 is a multiple of 4? So we have 1, 2, 3 numbers. So 3 by how many total number of numbers? 15. So 3 by 15, 3 1s and 3 5s. So which is a 1 by 5. 3 by 15, which is a 1 by 5. Right? So let's try to continue one more question. Ashrita throws 2 normal 6-faced dice. So what is that 6-faced die? So these are called dice, you know that, right? When you play the Ludo game or whatever the game is, you use this one. Find the probability of getting the sum of the numbers on both the dice at least 11. At least means the count should not fall below 11. The count may be 11 or maybe 12, but not more than that. Why? Why the number cannot be more than that? Because she's throwing 2 die. She's throwing 2 die. So 6 plus 6, the maximum they can get 6 plus 6 is 12. But here the question is at least 11. The probability of getting the number, sum of the numbers is at least 11. So let's try to see what are the cases. Let me write all the cases. So we have total 2 dice. One die will have 1 to 6 options, and other one will also have 1 to 6. Let me write all the outcomes for you. What are all the chances we are having, right? So let me write down this. So there are 6 and 6. So 6 into 6, we generally get 36 possible outcomes. 36 possible outcomes. Let me write all this, right? So 1, 1 is one case where when you throw both the dice, the first die giving you 1 and the second die give you 1. Total is 2. In the same way we have 1, 2. In the same way we have 1, 3. 1, 4, 1, 5, 1, 6. Right? 2, 1, 2, 2, 2, 3, 2, 4, 2, 5 and 2, 6. 3, 1, 3, 2, 3, 3, 3, 4, 3, 5 and 3, 6. The next one 4, 1, 4, 2, 4, 3, 4, 4, 4, 5, 4, 6. 5, 1, 5, 2, 5, 3, 5, 4, 5, 5 and 5, 6. And the last one we have 6, 1, 6, 2, 6, 3, 6, 4, 6, 5 and 6, 6. So in total at least 11. We should get at least 11. So not in total how many cases are there? Don't take this as 21, 22, 2, 1, 2, 2, 2, 3, 2, 4, 2, 5, 2, 6, 3, 6, 3, 5, 3, 4, 3, 3, 3, 2, 3, 1, right? So all these are the numbers shown by both the die. Right. Okay. So now we should get a sum of at least 11. If we should get a sum of at least 11, so carefully observe, I'll try to plot which all the numbers that we're having. So where we get the count is 11 or 12, 1 plus 1 is 2, 1 plus 6 is 7, so we don't get anything here. 2 plus 1, 3, 2 plus 6, 8, no. Let me cancel that, which are not possible. These are not possible, these are not possible. 3, 1 is 4, 3, 6 is 9, no. 4 plus 1 is 5, 4 plus 6 is 10, still we didn't reach 11. So 5 plus 5, 10, 5 plus 6, 11, 5 plus 6, okay. So 5, 6 is one option. 6, 1, 6, 2, 6, 3, 6, 4, 6, 5, 6, 5 is 11 and 6, 6 is 12. So that means out of the total 36 cases, whatever we are having here, out of that only 3 are favorable to us. Out of the total 36, we are having only 3 are favorable to us, right? So out of 36, only 3 are favorable. So number of favorable by the total number of cases 3 by 36, that is 1 by 12. So that is a probability. 1 by 12. You can leave it like that, or you can try to bring that into decimal numbers by dividing 1 by 12, right? So that is how you can try to bring all these relations, all these cases. We totally get 36 cases here. Right, 2 dice. Next one. A coin is tossed 3 times. A coin is tossed 3 times. So when you toss a coin, you either get head or tail. You know that, right? You either get a head or tail. That means when you're throwing 3 times, all 3 cases are important. The first one you may get tail. The next you may get head. The next you may get head. So we need to write all these possible cases such that finally, we need to understand, or we need to calculate the number of cases where getting head and tail alternatively. That means the first if you get head, the next you should get tail. And again, you should get head, or tail, head, tails. Okay, so all those cases. Now, let me tell you how many actual total outcomes are possible. Total outcomes, I'll write you here. I'll tell you here. So let's see here. Toss 3 times. So let's say this is the first time, the second time, and this is the third time. So let me write all this 1, 2, 3. The first one, a coin is tossed 3 times. What is the probability of getting head and tail, at least alternately? Tail alternately. So let me write all the cases. Tail, tail, tail. That is one case. When all the 3 coins tossed will give you tails. Tail, head, head, tail, and head, head. Right? Tail, 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 tail. So these are the first 4 possibilities. Next, H, T, T, head, tail, tail, head, tail, head, 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 tail, and head, head, head. So this is how all the 8 outcomes will be there. Now, what is the probability of getting head and tail alternatively? Head and tail alternative, right? So we can see here, these are all tails. No, that will not happen. That will not count to us. So this is wrong. Tail, tail, head. What is the probability of getting head and tail alternate? But here, see here, tail is there, tail to tail. We are not getting any difference, right? Tail to tail, which is not alternatively. So even this is wrong. Tail, head, tail, it is correct. T and then H and then T. This is correct. That is the first one. The next, tail, head, head. That is wrong again because we are getting 2 heads alternatively. Okay. Head, tail, tail, 2 tails. Wrong answer. Head, tail, head. That is correct. Head, tail, head. So that is correct. That is how you get those 2. The alternately heads and then tails and then heads. Right. Next, head, head, tail. That is wrong. Head, head, head. Even that is wrong. So how many cases are the total? Favorably, we have 2 cases, but the total number of cases is 8. So 2 by 8, which is 1 by 4. 2 by 8, which is 1 by 4. So you have total of 1 by 4. I mean, total 2 cases out of 8 cases. The probability is 1 by 8. The probability is 1 by 8, right? Sorry, 1 by 4. Moving ahead, a die is thrown. Find the probability of getting an even number. You know what is a die? What happens when we throw a die? Okay, so throwing a die, when we throw, we get either 1 or 2 or 3, 4, 5 or 6. Now the question is, find the probability of getting an even number. Find the probability of getting an even number. So this is 1, this is second one, and this is third one. So these are 3 numbers, right? Find the probability of getting an even number 1, 2, 3. So we have total 3 cases. So 3 by 1, 2, 3, 4, 5, 6, 3 by 6, which is 1 by 2. 3 by 6, which is 1 by 2, right? So find the probability of getting an even number is 1 by 2, or if you can divide 1 by 2, you will get 0.5 as the probability. In general, probability we always represent in fraction or in decimal. Both are correct. That's not a mistake, right? You sometimes write 1 by 2, sometimes you write 0.5, right? The next one. The probability of all the events in a sample space adds up to 1. Yes, this is exactly correct. The probability of all the events in a sample space means, let's say one event, let's say one experiment. Tossing a coin, that is one experiment. Throwing a die, that is one experiment. Right? In that, what all the probabilities we are talking about? So sum of all those will add up to 1. Sum of all those will add up to 1. So that is what this statement gives you. let's say probability of getting a tail or probability of getting some A, let's say probability of A is, let's say, 0.7, and A, B are the events. If not A, then B. If not B, then A. There are two outcomes here, like head and tail or something like that. Okay. So if I want to find probability of B without giving any other information, but I know that these two are the events in the same space, right? So then I can say that these two should add up to give you 1. So definitely probability of B will give you 0.3. Definitely probability of B will give you 0.3. 0.7 and 0.3, that will give you 1. Right. So moving ahead, right? So that answer is yes, that's exactly correct. 11 bags of wheat flour, each marked 5 kg, actually contain the following weights of flour. Okay. So there are 11 bags of flour, but actually we thought that each one is of 5 kgs. But here, what happened? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 bags are there, but not all of them are equal to 5. They are either greater than 5, or they're less than 5, or they're also equal to 5. Less than 5 cases there, greater than 5 cases there, equal to 5 is also there. Now the question is, what is the probability that any of these bags chosen at random contains more than 5 kg of flour? What is the probability that any of these bags chosen at random contains more than 5 kgs of flour? So in this case, tell me how many bags are there whose weight is more than 5? I know the total count is 11. There is no change in that. But how many are greater than 5? So 1, 2, 3, 5 is not greater than 5. That is the only mistake you do. 5 is equal to 5. The question is more than 5 kgs of 5 cannot come. 5.06 can come. 5.08 can come. 5.04, 5.07. So now tell me how many cases, right? So 1, 2, 3, 4, 5, 6, 7. So total, out of 11 we are having 7 cases. Out of 11 we have 7 cases where the probability is more than 5 kgs. The probability is more than 5 kgs. 1, 2, 3, 4, 5, 6, 7. Okay, right? So that is how you try to find the probability. Very simple question. Let me tell you one more. In a survey of 364 children aged 19 to 36 months, right? We are taking a survey. It was found that 91 like to eat potato chips. Okay, so many of you like that. Many of you like potato chips. Even I like that, right? So 91 liked to eat potato chips. If a child is selected at random, the probability that he or she does not like to eat potato chips is. See, out of the total 364 children, we know 91 children already like that. Already like potato chips. But the question is, how many does not like? So we need to find the number of students who don't want that, number of people who don't want that. 4 minus 1 is 3. 36 minus 9, if I'm not sure, 16 minus 9 is 7, and 273. Is that correct? 16 minus 9, correct? 273. Now the question is, what is the probability that he or she does not like to eat potato chips? So 273 is the number of people who does not like potato chips divided by the total count is 364. The total count is 364. But still, we have answers like 0.25, 0.50, 0.75, 0.80. Let me calculate that. Okay. So we need to cancel that maybe with 9. This is with 9 and 1, right? Let me check with 91. 91, because 91 is also there. Maybe some hint. 91 3s. 3 1s 3, 9 3s 27. Exactly correct. And what is 91 4s? Now 4 1s 4, 9 4s 36, 364. Okay, so this is just a hit and trial method. I thought of 91 because 27 and 3, it is a 9 type. With 9 we can cancel that. I mean, with 3 we can cancel that. 3 91s, and here also with 3 we can cancel that. It is again 91s. Okay, I mean to say with 4s. Okay. So, which is equal to 3 by 4 when you divide with 11, when you divide with 91. So, 3 by 4 is a 0.75. I will tell you how is 3 by 4 is 0.75. 4 and 3, so 0.04. 4 7s are 28, you're left with 2, 0. 4 5s are 20. 4 5s are 20. So, that is a 0.75. That is a 0.75. That is how you try to bring all this, right? So 0.75, option C is the correct answer. Let's move to more questions on these applications. In a sample study of 640 people, so there are total 640 people who are studying, okay, it was found that 512 people have a high school certificate. Out of 640, 512 people have high school certificate. If a person is selected at random, the probability that the person has a high school certificate, the probability that person has, so 512 are the people who have the same probability is being asked. So we need to find 512 by 640. So we need to find what is the value, 0.5 or 0.6, 0.7 or 0.8. Let me calculate that. Let me divide that with few numbers. Maybe with first we can cancel with 4, I think. So 4 ones are 4, 4 twos are 8, then with 3, 4 8s, 128 by 460. 4 ones and 2, 4 16s, 160, 128 by 160. I think we can cancel once again with 4, right? 4 3s and 4 2s, and this 4 40s, 32 by 40 with 8, I guess, right? With 8 you can cancel. 8 4s, 8 4s 32 and 8 5s. So 4 by 5, let me calculate that. 5 and 4, 0.05, 8s are 40. 5 8s are 40, that is enough to say that 0.8 will be the probability. 0.8 is the probability of the people selected having high school certificate. But if the same question is asked for people who don't have high school certificate, instead of doing that again complete thing, as you know the total sum should be 1. So 0.8 is the people who have the certificate and 0.2 are the people who don't have the certificate. 0.2 people are the people who don't have any certificate, right? Next one. A bag contains 16 cards bearing numbers 1, 2, 3 and so on to 16 respectively. One card is drawn at random. What is the probability that a number is divisible by 3? It's a very, very simple question. A bag has 16 cards, right? And every card has a number 1, 2, 3 and so on till 16. So now, from 1 to 16, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. What is the probability that a number is divisible by 3? What is the probability that a number is divisible by 3? Right, so by 3, so 3 is divisible by 3, 6 and then 9 and then 12 and then 15, 1, 2, 3, 4, 5. So total 5 out of the total 16 numbers. So 5 by 16 is the probability. 5 by 16 is the probability of a number selected at random between 1 to 16 is divisible by 3. Is divisible by 3, right? Okay, so moving ahead. A die is thrown 300 times and odd numbers are obtained 153 times. A die is thrown 300 times. So 300 times you are throwing and odd numbers are being obtained 153 times. Odd numbers are 153 times. Then find the probability of getting an even number. You know, either we get odd number or whether we get an even number. There is no other possibility. So definitely, if odd numbers are 153, even numbers will be 300 minus 153. 300 minus 153, so 10 minus 3 is 7, again 9, so 9 minus 5 is 4 and 2, right? 153 and 247, so that will give you 300. Now the probability of getting an even number. What is the even number here? Even numbers are 247, so 247 by 300. If you can cancel, please try to cancel that. 7 plus 4, 12, then 14. I don't think we can cancel 5, but if you have any other multiple, so please try to cancel with that, okay? So that is the probability of getting an even number. Now, okay, so I think you understood all these lectures, right? All these questions. In the coming class, we're going to discuss more applications based on probability, and we're going to discuss more advanced level applications on all the probabilities, right? This is a very, very important topic and very beautiful and very interesting topic. Thank you so much, students. I hope you understood all this. In the coming class, we are going to discuss more about all this. Thank you so much.